Hello everyone, let us now begin Chapter 2, Descriptive Analysis and Presentation of Single Variable Data. This Chapter 2 and the first half of Chapter 3 will cover the descriptive statistics part. The rest of the semester will be devoted over to inferential statistics and its theoretical background, probability theory. In other words, we don't have much time talking about this descriptive statistics. So everything we discuss here is something important. First, we're going to talk about graphical presentation mechanisms. There are two sections here. 2.2 is about histogram, the most important item, and everything else is dumped over to 2.1. And from 2.3 to 2.7, we discuss various numerical descriptions, what those numbers are for, how they are defined, what do they mean, things like those. Okay, let's go to our notebook and let's begin discussing graphical presentation mechanisms. We just initialized it, so we are ready. The first is the bar chart. The first is the pie chart, Bar chart is the next one. Okay, here's an example of pie chart. Let's suppose we have a class and out of 23 students, 1 student earned A, 6 students earned B, 10 students earned C, and so on and so forth. And we have pie chart like that. And each slice of pie has a central angle, and the central angle represents the relative frequency or the proportion. For example, if a certain category has precisely 25%, which means 1/4, then we have to have 1/4 of 360 degrees, which is 90 degrees. In this case, the total number of students is 23, which is a prime number, so we don't really have those nice angles. Next is bar chart. I'm sticking to the same example, same class actually. So here we go. Out of 23 students, 1 student earned A, 6 students earned B, 10 students earned C, and so on and so forth. And we have this kind of bar chart. And in this bar chart, the height represents the frequency, how many A students are there, how many B students are there, and so on. And of course, if you want proportion, like pie chart over here, then we can divide everything, all these numbers, by 23, and we're going to get decimals or percentages, depending upon where you look at. Bar chart can be a little bit more inclusive. It can go a little bit further than pie chart. In pie chart, the total has to be 360 degrees, so you can work only with proportions. But bar chart, they don't really have to all add up to full 100% if you have unrelated data categories, or if there are some overlaps and things like those. Next, let's talk about Pareto diagram, and it's kind of strange thing that I will probably not deal with in this class, because this is good only for nominal variables. This is what it does. It has bar chart for relative frequencies, and then those line graphs for cumulative frequencies, but it does something funky. It rearranges everything in most numerous to the least numerous. So it doesn't really work well with ordinal data. It works only for nominal data. In this case, we have letter grades A, B, C, D, and F, which is clearly ordinal. And if you look at Pareto plot, we have rearrangement. C is most numerous, B is next, D is next. So we have rearrangements there. So it's not really good. Much better explanation, much better use of Pareto diagram will be given in our textbook. After finishing this notebook, let me go back to our textbook and explain, well, how things look like over there. No, let me change my mind. Let's do it right now. Let's pause. Okay, here it is. Here's an example of Pareto diagram in our textbook, and they used FBI report and found out proportions of hate crimes on race, sexual orientation, religion, ethnicity, and other. And those are not ordinal, those are just names. You cannot put any kind of order there, so it's okay to use Pareto diagram and change the orders according to the most numerous to the least. The most numerous is hate crime against race, and in terms of frequency, 4,574 counts were observed in the year 2003 according to FBI report, and that is 52.5% of all. Next, sexual orientation, 1,430 counts of crime, that's frequency. Relative frequency is that one divided by total, 8,715, which we have 16.4%. If you add up those two percentages, 52.5 plus 16.4, we get 68.9%. That's cumulative percentage. Do the same thing for the next one, religion, and cumulation is 85.3%. Add up 68.9 plus 16.4 again, and do the same thing again, do the same thing again. What do we get? We get that line graph as you see on top, and we have those bar graph. That combination is called Pareto diagram, and because it rearranged automatically to most numerous to the least, you just use it only for nominal data. However, in this math class, we hardly use nominal data, as a matter of fact. So we don't really use Pareto diagram very often. By the way, here are some other cases. Here's an example of pie chart in our textbook here, and then an example of bar chart here. Pie chart, we are looking at percentages and they all have to add up to full 100%. Bar chart, not necessarily. So yes, of course, we can divide everything by the total number and get percentages, but not necessarily. That's one distinction between pie chart and bar graph. Okay, let's go back to my notebook here, and let me show you the next one, dot plot. Let's go back to this hypothetical class. Excuse me, I take it back. This is not hypothetical, and this is actual grade curves I got from a certain exam I gave. If I remember correctly, it was a midterm exam of a certain class, which I will not reveal which semester. Of course, student information is confidential. In any case, this is actual figure, and furthermore, here are actual scores rearranged from the lowest to highest, and 33 is the lowest and 94 was the highest. And then as you can see, we have some repetition of same scores. Yes, that happens. A lot of students score the same score. And in this case, 4 students score 77. And not coincidentally, we have 4 dots right at 77. And 2 students score 79, so we have 2 dots at 79, and so on and so forth. So this kind of thing is called dot plot, and it shows not just, it shows distribution pretty well. What can I say? And then as you can see, this 33 may look like an outlier that we may have to throw away. Okay, another important class is stem and leaf diagram. Let's stick to the same data. This time, let's categorize these dots into a class. For example, there are many dots between 70 and 80. Put everything together and then put all those together as, well, C students between 70 and greater than or equal to 70 and less than 80. And then D students greater than or equal to 60, less than 70, and so on and so forth. And then we can put those together into stem and leaf diagram, as you see over here, down here. The lowest number is 33, and 10th digit is 3, 1st digit is 3. And as you can see in the stem and leaf diagram, we have 3, 3, that corresponds to 33. Next, we have 5, 8. 5 is the 10th digit, 8 is 1st digit. What do you get? 58. And then next we have 64, 67, another 67, 69. Those corresponds to the third row. We have 6 in the 10th digit because these 4 numbers all share the same 10th digit, 60s. And the 1st digit are 4, 7, another 7, and 9. and those are the leaves. You have exactly the same structure in 7Ds. They all share 7Ds, and then 2, 3, another 3, 5, 7, 7, 7, 7, and 9, 9, and so on and so forth. So this is an effective way to represent the distribution, score distribution. There's a pros and cons, and pro is, well, let's see, we can not only find out the rough distribution by we have a lot of digits, a little bit long bars forming up around 70s, and then next one forming in 80s, and so on. We can see those distribution accumulation, and also we have those numbers. So that's both of them are advantages. Disadvantage, it works only for division by 10, 10th digit and 1st digit, and the others are kind of difficult. For example, if you want to categorize into every 15, I can't use the stem and leaf plot. 10th digit I can do, and if you have 3-digit number or 4-digit number, then you can use different stems. Okay, dot plot and stem and leaves, they are both effective way to represent entire distribution. Let's see, do I have enough time to go to histogram? Probably not, so let's go to our textbook, and then let me show you some stem and leaf plots and dot plots in our textbook. Let's see, dot plot, here's an example of dot plot, kind of like what you see before. They use exam grade here as well. Actually, this was an inspiration. Our textbook author used exam grade, and I have a lot of exam grades accumulated, so I just went back to one of my classes I had and used those. And here's an example of a stem and leaf, and we have 10s in the left hand side and 1s in the right hand side, and we have this kind of stem and leaf display, same thing as we saw before. Let's see, do we have any other kind of stem and leaf? Oh yes, other kind of stem and leaves. In this case, we have weights of college students, and then we have 2 digits, 100 and then 10th digit as stem, and then leaf as the first digit, and we have this kind of distribution as you see on the left hand side. But as you can see, we have 2 peaks. We have 11 in which means 110 something, 100 and let's see, between 110 to 120 we have a peak, and then we have another peak between 150 to 170. And what's causing these 2 different peaks, which we call bimodal, by the way, one peak is called a mode, and it is related to genders, so they can produce kind of double-sided stem and leaf display, as you can see in 2.8, where females for the left hand side, males going to the right hand side, and put those together, and we have 2 sets of stem and leaf displays put together, and they explain female and male data separately. We can do these kind of things with stem and leaf display as well. But what can I say? I really hate to say something interesting and then, oh, by the way, I'm not going to write this kind of thing in the exam, kind of things like that. But I may end up doing that, really, because you see, the overwhelming majority of this course will be devoted to inferential statistics. So this descriptive statistics will be kind of hit and miss. Something will come up, something will not. And definitely we are going to see something on histogram. The others will be kind of hit and miss. Among those, one of the more important is stem and leaf display. But then again, I cannot really go too deep. So go figure, I did not definitely exclude stem and leaf or harder things about his stem and leaf, but I left a little bit of leeway, but still there was some implication which is important, which is not.